Set, go. Welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video. This is notes number 2, roots and radicals expressions part 2, because this is just a continuation of yesterday's, not actually a whole different concept. It's just one more thing that we need to add on to yesterday's. So, first things first though, guys, this is going to help you moving forward any time you're taking a math class, like when you go to college and stuff like that. But you want to know the difference between instructions, okay? So when you read instructions, hopefully you actually read them, you know what it's even talking about. So first of all, if the instructions say real roots, i.e. give the real roots, or what are the real roots of blah, that means that they're looking for you to give the positive and negative roots. Alright, so the real roots are positive and negative roots. So for example, if we asked you to give me the real roots of 4, so square root of 4, give me the real roots, what would that answer be? Plus 2? Plus minus 2, right, because that's the real roots, positive and negative. Now, it's different than principal root. What does principal root mean? Thank you, very good. Positive roots. We got people who can answer the questions. Positive roots. So, what would the principal root of square root of 4 be?
2.
There we go, good. And keep in mind though, principal roots really only apply to even index. I'm going to put usually so that way we're not wrong. Usually only apply to even index. Yes, because this is very important. Usually only apply to even index, because people will be trying to like apply this concept to, odd index things, and it doesn't really make sense that much. All right, now here's the last thing though. When it's not specific, for example, look at these problems down here where it just says simplify the following. It doesn't say anything about real roots, doesn't say anything about principal roots. Not specific, just to be safe, guys. This is especially important when you go into college and things like that. You don't want to just assume what your professor or your teacher's looking for, right? Because especially when we get into square roots, the way you say things and the definition, depending on the teacher, that's going to change what they're looking for. So make sure when it's not specific, just be safe and just ask your teacher. What are you looking for? Do you want just the positive ones or do you want both? Okay, so just ask the teacher. When it's not specific. Do I want both? No, just give the principle. So we're going to see right here. This first example is to establish how we're going to be doing it now. All right, to keep it consistent with everybody else. Simplify the following. Unless specified otherwise, only give principal roots. So what are we looking for if it says only give principal roots? Right, just the positive roots. And now, you see it says unless specified otherwise. So now, on this whole paper, unless it says real roots, then only give the principals. So number 1, what is the principal root of 36x 20 to the 26? 6, right? Because 6 times 6 is?
36.
That's right. And then? X to the?
13.
How did you get 13?
Divided.
Divided by 2? Where's the 2? I don't see a 2.
Put the 2 on the left.
Right. And what is that number called right there? Anybody? What is it called? The little 2 right there on the radical. That's not an exponent. Starts with an I. Starts with an I. Yeah. Index. There you go. Good. So 6x to the 13. However, remember this question, it says to only give the principal roots. That means your answer should be positive. How do I know this number right here, 6x to the 13, is going to be positive? Because if I plug in a -1 for x, that's going to be a negative. So what? What is that called? Absolute value. Around what? X to the 13th. Right. So this is very important. Make sure you hear this. When you have an even index only even index, you need to worry about having absolute values where it should be. Okay? Absolute values only go around the odd exponents because you don't know if odd exponents are going to be even or odd. Even exponents are always going to, even exponents are always going to be, I said even or odd. You don't know if odd exponents are going to be positive or negative. Even exponents are always going to be positive. Do you know why that is? Does everybody understand why even exponents are always positive? then that doesn't really explain why the number would come out to be positive on the exponent. You put that there. And that's not around the even exponents. All right, well, check this out. So what is the smallest even number besides 0 that you can think of? 2. So if you had an exponent of 2, right? For example, look, x squared, right? That means I'm multiplying a number by itself, right? Like this. So let's say the number was positive. Then I'd be multiplying it by itself, which is a positive. That comes out to be?
Positive.
So if that number is negative and I multiply it by itself, which is a negative, what would that come out to be? Positive. So now I've just proved that it's always going to be positive for 2, right? And then this is how you show that it's always going to be positive for any even number. Because 2, any even number is divisible by 2, right? So no matter what my exponent is, watch. If I change this to a 4, I'm going to add another pair of these negatives here, right? But as we know, a pair is going to be positive. So I'm just multiplying more positives. Because look, when I put the x to the 4th, what did I just add? These two negatives multiply each other to make a positive. What about these two? And that's still a, right, and this just continues on, you see? So that's why even exponents are always going to be positives. All right, so anyways, there's that. Number two, would we have to worry about absolute values on number 2? No, why not? Because what? Because what? That is not how you tell if you have to look at in absolute values or not. If what is? If the index is even or not. Is this index 3 even? No, so we don't have to worry about absolute values. So we can just solve it and leave our answer. So what is the cube root of 1,000? 10. Because cube root tells us, okay, what multiplies itself by 3 times to give 1,000? That would be 10. Very good. So it's going to be 10. And then what about the x? Just x to the first, right? And then? Y to the 9th. Right, very good. And that's your answer. You don't have to worry about absolute values. So there it is. Good. Now, here's the add-on to yesterday that will complete this whole mini unit. So let's take a look at these two examples. This part right here, it says when variables are not perfect roots. So we're going to compare these two examples. Number 1, first of all, would I have to look for absolute values on number 1? No. Yes, why?
Because the index is even.
The index is 2, which is even, right? So that's when you have to look for absolute values. Okay, so now can you solve this? What is the square root of x to the 8th, y to the 18th? And then? Y to the 9th, right. Where should my absolute value bars go? Around the y to the 9th, right. When you have even index, you have to use absolute value bars. And the absolute value bars go around odd exponents. That's the answer. So there was nothing really wrong with that one, right? That one was pretty easy. Nothing new. But then look at number 2. How would we do this one? Cube root of x to the 9th, y to the 14th. What would happen with the x? X cubed, right? But then look at the y. The exponent is 14. Does 3 go into 14 evenly? No. So what do we do in this situation? Well, that's what we're about to find out. What you're going to do is you're going to divide the exponent by the index as many times as possible. So how many times does 3 go into 14? It goes into 14 4 times? So, yeah, it does. It does. So y to the 3rd, as you said, it goes 3 full times, right? Or 4 full times, sorry. 4 full times. And how much is left over? Wait, what? 2.
Sorry, 2.
Yeah, 2. So then you're going to keep that, wrong color. You're going to put the cube root and then keep the 2 that you said was remaining as the exponent on the inside. Another way to see this is to go back to elementary math. Remember, before you learned how to divide and before you learned how to get decimals in division, you did like this. Look, 14 divided by 3. How many times does 3 go into 14? 4. 3 times 4 is 12. Remainder, 2. And then look at that. This 4 that we're able to divide comes outside as the root. The remainder stays on the inside. And that is it. So that is the concept of when variables are not, or anything is not a perfect root. So let's do some examples. We got 6 examples. Number 1, would we have to look for absolute value bars on number 1? On example number 1 right here, or the first problem in example 2. Would we have to look for absolute value bars?
Yes.
Yes, why?
Because the index is even.
Because the index is 2, it's even. Okay, so what is the square root of 144? 12. Okay, now with the 10, does 2 divide into 10 evenly?
Yes.
So what's it going to be? X to the 5th? Right. Now does 2 divide into 5 evenly? No, so if you want to see it clearly, look, 5 divided by 2, how many times does it go in? 2. 4 minus, so the remainder is 1. So on the outside it's going to be what? Y 2. The remainder remains on the inside. Square root of y 1, which is just y, right? So you don't have to write that. So that's it. However, remember we need to look for absolute value bars. So where should the absolute value bars go here? X to the 5th. Remember, it goes around odd exponents. And this is your answer. So let's try number 2 then. On number 2, would you have to look for absolute values? No, why not?
It's cube.
What is?
Square root. The radical.
The radical?
Yeah.
So can somebody explain how you would actually say this? How you explain?
Wait, explain what?
So number 2, you don't have to use absolute values, right?
That's because the index is odd.
Because the index is odd. Right, there we go. Okay, so let's solve it then. What is the cube root of negative 64? Negative 8. That seems like a really big number. Negative 8 times negative 8 times negative 8 is huge. 4, negative 4. Very good. So negative 4. Then I'm going to go ahead and put the cube root here so you can tell me what goes on the outside or what goes on the inside. So with the 4, does 3 divide into 4 evenly? No, it doesn't. How many times does it go into 4 evenly? Once, and then subtract 3. What's the remainder? Remainder 1. So what goes on the outside?
1.
I just write a 1 here?
No.
What do I write? X. What goes on the inside? Just X, that's right. Because the remainder is 1. You could think of this as putting 1s there, right? But there's no point in writing the 1 as the exponent. Okay? Next, does 3 go into the 8 evenly? So let's see. 8, 3, how many times does it go? Twice. And what's the remainder here? Remainder 2. So what am I going to write then?
2.
Y?
Y squared.
Y squared. And then on the inside?
Y squared.
That's right.
Just y.
Okay. And then what about the z term?
4. Z4 to the 4.
Z to the 4th. Anything left on the inside? No, because it divided perfectly. And there we go. That is your answer.
Is that a 3 right there?
The index is a 3, yeah. Yeah, be careful about that. Look, when your problem started, you started with a cube root, right? So when you write it again, it still should be cube roots. Yeah.
Why would it ever like use it?
I don't know, man. Not exactly sure. Not exactly sure, to be honest. Some high-level science or math or computer science, things like that, you know. You're taking Algebra 2 class. All right. Besides, anyways, you got to keep your options open, you know what I mean? You don't want to limit your options here, especially when you have all the potential in the world. Just kidding. All right. Number 3. All right, number 3. Would you have to look for absolute values on number 3?
Yes.
Yes, you would. Why?
Because the index is.
Because the index is even. That's right. Okay, so let's go ahead and can you tell me the answer without me drawing the remainders here?
So is it X
X.
X, and then what's on the inside?
Y5 with, oh no, X cubed on
X cubed on the inside, right?
and then you put Y5 after dx.
Right.
And then Z cubed, and then Z squared on the inside.
And that is correct. That's right. However, what do we say we need to look for? Absolute value bars, right? So where should the absolute value go here? Just y and z? And x. Because the exponent on x is 1. That's an odd number. Exponent on y is also an odd number. Exponent on z is also an odd number. So we need the absolute value around all of them. So we can just go ahead and write it like this. And that's it. Boom. Okay. Probably on Tuesday or something like that. All right, number 4. Number 4. It says the cube root of 16 x to the 11th y to the 18th. Do we need to look for absolute values when we're finished with this one? No. Because the index is odd. It's a 3. Okay, so now this one's a little tricky because is there a cube root of 16? No, there's not. There's no number that will multiply itself by itself 3 times e of 16. So what we're going to do here is break down 16 into a base and an exponent. So can you tell me 2 numbers that multiply to make 16?
4.
So 4 and 4. What numbers multiply to give you 4 though?
2.
So 4 is 2 times 2, right? And then this 4 is 2 times 2. So that means 16 is actually 2 to the 4th, isn't it? 2 times 2 times 2 times 2 makes 16, right? So we're going to rewrite the 16 as 2 to the 4th. So now we're looking for the cube root of 2 to the 4th, x to the 11th, y to the 18th. And we're going to do the exact same process that we did with the variables and exponents to the 2 and the exponent on the 2. Some people get confused because they're like, okay, well, 2 is an actual number. What do I do? No, it's the exact same thing. You do the exact same process. So you could just pretend like 2 is not even a number. It's just a thing that's there if you want. All right, so let's write our final answer then. So I'm going to put a cube root here and tell me what goes on the outside and what goes on the inside. Okay, we'll start with x then. X what? To the 3rd, and what would be left on the inside? X squared, right. Okay, so that process that you just did, do that same thing to the 2 to the 4th. So what would be on the outside? 2. What would go on the inside?
1. X.
No, you're right, the exponent is 1. But look, what is the base? It's a 2.
Yeah.
So we're just going to put a 2 on the inside then.
Oh, okay.
So it's like the exact same thing except 2 is your base, right? But the process was no different. All right, and then what about the y? Y to the 6th on the outside, and that's your answer. The 4 on the 2? Because how many times does 3 go into 4? 1, so there's a 1 right here. And what's left over? 1 again, so there's a 1 right here too. You just don't need to write the 1 so you don't see it. But you see how you did the exact same thing though, right? That you did to the variables? Okay, so let's go to the back side then. Last 2. Number 5. All right, so these ones, it really probably does require you to separate it into a top and the bottom, okay? When you see the whole fraction, it looks a little confusing, but this is the same thing as saying the cube root of the top, so cube root of 27g to the 10th over the cube root of 8h to the 6k to the 12th, because we can solve these separately, right? So let's do that. What is the cube root of 27g to the 10th? 3, right? Because 3 times 3 times 3 is 27. So 3. Then what happens with the g? G cubed, and then cube root,
And then G.
and then just g, right? Okay, that's the top. Now let's find the bottom. What is the cube root of 8?
2.
2. And then what's going to happen with the h to the 6th?
H squared.
That's right. And then the k to the 12th?
K 4.
To the 4th. That's right. Because the 6 and the 12, they're divisible by 3, right? That goes evenly. And so that's your answer right there. You don't have to worry about absolute value bars because the index is odd. It's a 3. Wait, what?
You're doing the bottom like this.
Wait, that's the answer?
That's the answer, yeah. What are you asking? Last problem right here, number 6. Number 6 is the same thing as saying the 4th root of the top 256 g to the 11th over the 4th root of h to the 4th k to the 16th. Who knows? Who can tell me what the 4th root of 256 is? That's 4. Wow, very good. So 4 times 4 times 4 times 4 equals 256. So 4 was the correct answer. 4. And then what happens with the g to the 11th?
Squared.
Squared.
Yeah. And then you put G3 on the inside, right?
The inside of what?
The radical or the
Square root?
Yeah.
This is a square root right here.
Oh, put the 4.
4th root. 4th root, and then you said, what is it? G.
Cubed.
That's right. Okay. Over what?
And then you just do just H and then K4.
K to the 4th. Right. Okay. Now this one. Is there anything else we need to do? That's not the answer.
It's even, so you have to have absolute value.
It's an even index, so you need absolute values. So where does the absolute value go? On the h, right? Because the exponent is 1 on the h, which is odd. And that would be your complete answer. That is the end of the notes. And that's the end of this mini unit. So until next time, fellows. See you then. Peace!